Everyone, welcome to another episode of µCast. We are on location today. Why? Because we need to build a power supply. We're tired of killing 9-volt batteries, doing all of our little circuits that we've been demoing, and so we need a super cheap and easy to make power supply that we can stick on our breadboard so we don't have to waste batteries anymore. For that, we're at the Goodwill. If you don't have a Goodwill, find a thrift shop to pick up. What we're going to use is a power supply from the wall. You can normally get these super cheap here, so let's go see what we can find.
I'm gonna pop some tags, only got $20 in my pocket.
Okay, back here, power supplies, hanging all around, various types. What we want to look is at two things. You get in on here. There'll be an input and an output. You want the output to be between 5 and 9 volts, and the current you'd want to be above 300 milliamps or so. Find those, buy a couple, they're cheap. These are $1 a piece here, sometimes you find them for 50 cents. Buy a couple, we'll take it home. Don't worry about the connector on the end. This is a mini or micro USB. Don't worry about that. We're going to hack it off anyway. Just dig through, take a couple home with you. Alright, we're back in the shop here. We've been to the thrift shop, we popped some tags, we bought ourselves a couple of power supplies that we can plug into the wall. And so what we're going to do with that is we're going to make a simple, cheap power supply that we can use, because so far we've been using batteries. Mostly we've been using this 9-volt. These things do not last forever and they're expensive. So we don't want to use these forever. We want to create a power supply that we can hook up to our breadboard, power our simple circuits with, so we don't have to waste money on these anymore. So let's come back down here real quick and remind you that when we picked these up, the important things we were looking at were the input is the right voltage AC, and then the output. I said that we want something between 5 and 12 volts. You can see this one is 7 volts and it has the current rating on it. So we got two of them here. Now, if you remember, I said to pick up a couple because there's two types of power supplies. There's regulated and unregulated, and I'm going to show you what that means here in a minute. So let's go ahead and I'm done. I can't sit down anymore. We gotta get in. This is ridiculous. Okay, so let's just take this and let's plug it in. Let's turn on our meter, 20 volts, and we're gonna hook one lead up to the outside and the other lead in the middle. Now, if you remember, this one said 7 volts. But when we plug it into our meter, if you can get that, it's actually at 10.3 volts. It's negative just because I have the leads hooked up backwards. This is an unregulated power supply, meaning it needs to have some sort of load, some current running through it to drop the voltage down to 7 volts. A lot of these are built for specific electronics that know how much current is going to run through them, and so they build these so that when that amount of current runs through them, the voltage drops down to that 7 volts that's listed on here. This is not what we want. We want a regulated power supply that even when there's nothing attached to it, it's giving us the voltage that it says here. So this one, if you bought it, I would suggest not using it. So let's take a look at this one. This one's 5 volts, and we'll go ahead and we'll do the same thing. Hook this up to our meter. This is just a way you can test them, and if you want, when you're shopping for these, take your meter with you before you buy one. Helps if you plug it in. Alright. Let's get that in there. So you see that is right on around 5 volts. Now don't let that says 5.1. Don't think that that's unregulated. That's pretty close to 5. That's close enough. That's good enough for our needs. So this is a regulated 5-volt power supply that we can use to power some of our circuits. So once you've found a good regulated supply that's the right voltage, just a quick reminder, I said 5 to 12 volts. If you have a higher voltage, you can always step that down with a voltage regulator. We'll show you how to do that in a different episode, but it's probably better to go higher than you need. 5 volts is going to be mainly what we're using. We might step it down to 3.3, so I would suggest at least 5, but you can go as high as 12 and be all right. Once you've got your power supply picked out, you've tested it, it's regulated, all we're going to do is make sure it's unplugged when you do this. You're going to take a pair of pliers and you're going to cut off the end. We're going to separate these out. Take our wire strippers and pull off a little bit of insulation. Okay. Now, the power supply will tell you on it which part of this barrel that we just cut off is positive and negative, the outside or the inside. Well, once we cut it off, that diagram doesn't do us any good. So we need to figure out which one of these is the positive and which one of these is the negative. Now, if you remember from the meter episode, we can easily figure that out. We're going to go ahead and attach this. And so if you'll notice here, if you can get on this, one of these has a white stripe on it. This one has no stripe on it. That's kind of a handy thing to help you know, to remember which is which. But we're going to go ahead and hook that up. Be careful when you're doing this. This isn't a lot of voltage. It's not going to kill you, but it'll take a bite out of you if you're holding both of the leads and you plug it in. So exercise some common sense and don't be stupid with these things. So we're going to go ahead and plug this in. I'm going to take this lead. I'm going to put it on. And you'll see, if we can get a good connection there, we'll get right up around 5 volts. Now that's reading positive 5 volts. Which means, if you remember, the common is like the negative, which means I'm correctly connected. This is the negative side, this is the positive side. If I'd hook this up backwards, like this, put that on, I'm going to see negative 5 volts. So remember, if you're seeing the correct voltage, that means you have them connected positive and negative the right way. So that means, in this scenario, so get up again, that's a positive 5 volts. That means this is my ground and this is my positive. So we'll just remember that. The striped version is the positive side. Come over here and unplug this. Okay. So, white stripe, positive, no white stripe, ground. So what you want to do is, I've just taken 2 wires here that I've stripped. I like to use green and black. Use whatever makes sense for you that helps you remember. I always remember green is ground. The G's go together, that's what reminds me. And black is hot. And so what we'll do is we'll take the green one here, make sure it's unplugged. Before we do that, you want to seal this off. If you've got some heat shrink tube, use that. That'll give you a nice clean finish on this. If not, just use some electrical tape. That works just as well. Just make sure you wrap it real good so there's no exposed wire. So I'm going to take this, I'm going to cut a couple chunks of shrink wrap. And I'm just going to wrap these together. Just get a good wrap on it like that, and we'll close it over. It helps if you bend it the way that you're going to slide this over. So we'll just slide that over like that. And then the stripe was our positive, so we'll just do the same thing. I'll wrap it. Kind of bend it back on itself there. Slide that through. If you never used shrink tube before, it's pretty cool stuff. You just apply some heat, it shrinks real tight. It's going to be much cleaner than a tape job, but like I said, a tape job will be just fine if that's all you've got. Just take a lighter or a heat gun or whatever you've got. You can even use a soldering iron on this if you're careful. We'll just heat that up all around. Same thing over here. Make sure you get it nice and tight. The skinny part. Do a little bit more over here. You can speed this up later, Bo. Alright, it's good. Just kind of make sure they're good and tight and they don't pop off on you. Okay, let's test it out. Let's get our breadboard here. We'll go ahead and connect our ground on this side, our positive on that side. I like to bend it out so it's not popping up there. Then we'll just put some test leads on here. We'll hook up our red is our positive one, so we'll hook it up to the black. And we'll just touch the green one here when we're ready to test it on ground. Plug this in. And when we touch this, we should see 5 volts run into our board. So let's give it a shot. And there you got it. 5.1. That's it. That's all there is to it. If you've got some of these lying around from Auto Electronics, pull it out, put it to good use. Find a regulated one. Just do a little bit of hacking together, splice the wires together, seal it off, and you got yourself a nice, cheap power supply. It's not anything fancy. You'll be surprised how much we can get accomplished with this. We don't need any fancy desktop power supplies. This thing right here is going to last us a good while as we go through our projects here. If you got any questions about that, leave some comments below. Let us know what you think. Case it out. Is there a problem?